Hello and welcome to today's podcast. This episode is brought to you by Beemit, a trusted manufacturer of precision electrical test and measurement instruments, delivering reliable solutions for modern electrical systems. Electrical systems often carry high currents that need to be carefully monitored to ensure both safety and efficiency. When these currents are not properly controlled, sudden surges can damage equipment, disrupt operations, and even create serious safety risks. This is where current transformers come into play. But when it comes to choosing between 1A and 5A ratings, the decision is not always straightforward. In today's podcast, we will break down how current transformers work, understand the difference between 1A and 5A ratings, and help you choose the right option for your system with clarity and confidence. So let's get started. To begin with, let's understand what a current transformer is. A current transformer, often called a CT, can be thought of as a ring-shaped device placed around a power line without directly touching it. Once installed, it detects the magnetic field generated by the current flowing through the conductor and converts it into a much lower, manageable current. For example, if a power line carries a very high current like 1,000 amperes, the CT reduces it to a safer level that measuring instruments can handle. In simple terms, it acts like a translator between high-power electrical systems and sensitive measuring devices, allowing safe and accurate monitoring. Now, let's understand the basic working principle behind it. A current transformer has two main parts. The primary side usually consists of a single conductor passing through the core, while the secondary side has multiple turns of fine wire wound around that core. When current flows through the primary conductor, it creates a magnetic field. This magnetic field induces a proportional current in the secondary winding. For example, in a 1,000 to 5 ratio, a 1,000 ampere current is reduced to 5 amperes in the secondary circuit. In simple terms, it works like a gearbox that reduces a high input into a controlled output that instruments can safely read. Now that we understand the basics, let's move on to secondary ratings and what 1A and 5A actually mean. The secondary rating of a CT indicates the amount of current it outputs when the primary system is running at full load. This standardization ensures compatibility with meters, relays, and protection systems. You'll commonly see only 1A and 5A ratings. This is mainly due to historical development and system compatibility. Earlier systems relied heavily on 5A because of robust analog relays. As digital systems evolved, 1A became more common due to its improved efficiency and accuracy in modern setups. Now, let's understand the key differences between 1A and 5A current transformers. A 5A CT is generally more robust and is widely used in traditional industrial systems and relay-based setups. On the other hand, a 1A CT is more efficient and provides better accuracy, especially in digital and remote monitoring systems. When we compare them more closely, a 1A CT has lower power loss and lower cable losses, which makes it more suitable for long-distance applications. However, its burden handling capability is lower. A 5A CT, in contrast, has higher power loss and higher cable losses, but can handle a greater burden, making it suitable for shorter distances and heavy-duty applications. In terms of accuracy over long distances, 1A performs better, while 5A may show slightly reduced accuracy. Typically, 1A CTs are used in modern digital protection systems, whereas 5A CTs are common in traditional relay systems. Now, let's understand an important concept called CT burden and power loss. Burden refers to the load connected to the CT's secondary side, including wiring, meters, and relays. It is measured in volt-amperes. If the burden is too high, it can affect the accuracy of the CT readings. Another important factor is how current affects losses. When current flows through a conductor, some energy is lost as heat. This is explained by the principle where losses increase with the square of the current. For example, in a 5A system, Higher current flowing through long cables leads to increased heat and voltage drops. This reduces accuracy, especially over long distances. Because of this, 1A CTs are often preferred in modern systems where long cable runs are involved. Now let's understand why 1A CTs are commonly preferred today. Since 1A CTs operate at lower current, they generate less heat, reduce energy loss, and provide more stable readings. This makes them ideal for modern electrical grids and systems where efficiency and accuracy are critical. Moving ahead, let's understand CT accuracy class and how it relates to secondary current. Accuracy class defines how precise a current transformer is. For example, a class like 0.5 is used for metering and allows a small margin of error, while classes like 5P are used in protection systems where detecting faults is the priority. The secondary current also affects accuracy. In systems with long cable runs, higher current like 5A leads to greater losses, which can reduce accuracy. In such cases, 1A CTs provide more reliable performance, especially in remote installations like substations. Now, let's understand when to use a 1A CT and when to use a 5A CT. A 1A CT is generally the better choice when the distance between the CT and the measuring device is long, typically beyond 100 meters. It is widely used in modern digital systems, smart grids, and large substations where minimizing losses is important. On the other hand, a 5A CT is more suitable for shorter distances, usually under 20 meters. It is commonly used in older systems and industrial environments where durability is more important than precision. Now, a common question. Can you replace a 5A CT with a 1A CT? The answer depends on system compatibility. You need to ensure that the relays and instruments can accept a 1A input. While many modern systems support this, some older systems may not. If replacement is possible, adjustments may be required in system settings. However, if the system is strictly designed for 5A, hardware limitations may prevent such changes. It is always important to test the system before making any replacement to avoid incorrect readings or unwanted trips. Now, let's understand how to select the right CT secondary rating. The first factor to consider is distance. For long-distance connections, 1A is generally the better choice. Next, consider the cable type. Thicker cables work better with 5A for short distances, while thinner cables are more efficient with 1A over longer distances. For high-load applications, 5A CTs are often preferred due to their higher burden capacity. It is also important to follow system requirements and applicable standards. If you are planning future expansion, choosing a 1A CT can offer more flexibility. In many cases, consulting an expert and evaluating system requirements carefully can help ensure the right decision. Finally, let's bring everything together. Current transformers play a critical role in making high electrical currents safe and measurable. While 5A CTs remain common in traditional systems and short-distance setups, 1A CTs are increasingly preferred in modern installations where efficiency, accuracy, and reduced power loss are important. Choosing the wrong rating can affect system accuracy and may even lead to equipment issues or missed fault detection. At BMIT, the focus is on providing reliable and efficient solutions that support modern electrical systems. Whether you are upgrading an existing setup or designing a new one, selecting the right current transformer is essential for long-term reliability. That brings us to the end of today's podcast on current transformers and the key differences between 1A and 5A ratings. Choosing the right CT plays a crucial role in ensuring safety, accuracy, and system performance. Thank you for listening. If you found this episode helpful, please like, share, and subscribe for more informative content. To explore reliable current transformer solutions, you can visit bmit.com. Let's wrap it up here. Thanks again for listening.